Thank you, everyone. Thanks for coming. Anthony Stinciani was going to give the bulk of this talk, but he has been called away on something urgent last minute, so you have to put up with myself and Trent for this one. We'll do our best to do it justice. So, as Stuart was saying, Science First is a fundamental transformation of this agency. And if you look up there, you can see a picture of the building as it looked like in the late 90s. And I think we all agree that a lot has changed and a lot is changing. We are in a very different place now than we were then, and that will continue on. So these are some words that Anthony gave me yesterday to make sure I pass on. So these are his words around the Science First Transformation Program, but obviously also words that I absolutely stand by. There are 4 streams in the Science First Transformation Program. It started about this time last year in earnest. The first stream, which is about the idea that commodity ICT, and I know a lot of people don't like that word, but it was used to describe the kind of ICT you can purchase, the ITC support that can be bought for money instead of having staff on site. And the idea there would be to transition our systems to cloud through a managed service provider to free up capacity for new capabilities in what's called scientific data and scientific computing. And the second stream is scientific data, the core business of GA. I heard it said recently that if this agency was to be decimated down to 50 people, those 50 people would be doing data services and data delivery. So the rest is the cream. And fortunately there's plenty of cream on top of that. But it is still our core business. Then there's this digital science capability and capacity, which is focused on advanced geoscience, and that will be the bulk of this talk, what that means for the agency and what we have found. And one of the things that are coming out of that is multidisciplinary agile teams, which is a new culture of value focus, collaboration and adaptability. We'll explain that in more detail. Now, we need to do this in a static budgetary environment. There's not going to be extra money to fund these things in the longer term, although there is quite a bit of a hump to get there at the moment, I have to acknowledge. But the capability we are seeking as we go forward is in very short demand, even if there was funding. So we need to work together to harness the skills that are required as we go forward. And we need to work together to reuse as much of each other's innovation as possible. And indeed, that is the very topic of the computational science workshop that is taking place in this agency as we speak. And we need to collaborate rather than compete for capability because it is in very short demand. So the digital science strategy is the reference point for direction and priority setting of all this. So without further ado, I'll dig into what we call the digital science strategy. About last year, this time, there was a lot of focus on what is known as scientific computing, which is pretty much the same as computational science. And that came out of the Science ICT network meetings in February and other things that happened. The CEO asked our CIO, Anthony Stinciani, if we could paint a picture of what scientific computing might look like in this agency as we go forward. And very quickly that picture, as we started painting it, became scientific data and computing, because obviously that was a very important part of it. And shortly thereafter, it became clear that scientific data and computing cannot exist without people. This is all about people. It cannot exist with the right processes around it and the right culture around it. So we adopted the term digital science, and I'll explain later where we got that from. It is a catch-all term for that modern digitalization of science. We formed a working group with about 35 to 40 representative subject matter experts from across the agency who all had input to this, and we had a number of sessions where we looked at what are the barriers to progress, where are the gaps, what's happening, what do we need to do. We also interviewed a lot of subject matter experts directly, and we met with branch heads and divisional chiefs as well to make sure we got a lot of input to this digital science strategy. So basically, what it is saying, and I alluded to that before, things are changing. Things are changing rapidly at the moment. It's called disruptive digital change, and no one is arguing with that, I believe. But for us, what that means is that information, for example, is expected to be available instantly, anytime, anywhere on our devices. this idea of sending a tape or a report to someone, those days have long gone. The complexities of the questions we are being asked completely exceeds what you can do one person with an Excel spreadsheet. They are questions around surface water, groundwater interaction. They are climate questions. They are model coupling. We have seen lots of examples in this workshop around some of the questions. It is about how do we create a geospatial datum of Australia that allows accuracy down to 1 centimeter? How do we compensate for continental drift? What are the mechanisms that generate subduction zone earthquakes? How can we maybe even predict them in the future? These are things that require dramatically different technologies, and it certainly requires the assistance of digital technology. The third one is obviously that data, the amount of data we are dealing with is growing. Our divisional chief for resources and minerals, James Johnson, he mentioned recently that when he did his PhD in the early 90s, I think, or 80s maybe, I actually don't know, but a while, last century, last millennium, when he did his PhD last millennium, he had about 20 data points in a spreadsheet, and he struggled to extract statistical significance out of those points. Whereas now it's the opposite. We have, a lot of points. We have a lot of data, and the challenge is really to make sense of that in a reproducible and quantitative way. And that's the challenges we have. And obviously there are unprecedented digital capabilities around as well. I mean, this phone can probably do more than a desktop could 15 years ago. And this curve, you can't see the details, but we all are familiar with the curve. Even if Moore's law is stopping, we're still going very, very much towards a situation where the complexity of our compute is up near at least a mouse brain, I think, on this one, which is quite significant. So a lot of things are changing. So we cannot just continue doing what we do right now, and there are lots of changes already in pockets in Geoscience Australia and the world. But these are the drivers. So we are saying it in short, science is becoming digital. There is no part of our world and no part of our science that escapes some level of digital involvement. So I found this analog computer there, I thought, which is not a digital computer, just to lighten it up. And this is the Google laser pointer. What do you reckon? So, because we're running it straight off a Google Doc that we have been collaborating on over the past couple of months. So, I talked about digital science. A really good description of that comes from the European Union's Digital Science and Horizon 2020. And they define digital science as it means a radical transformation of the nature of science and innovation due to the integration of ICT in the research processes and the internet culture of openness and sharing. It is more open, more global, more collaborative, more creative, and closer to society. It relies on ICT-based services and tools for data and computing-intensive research in virtual and collaborative environments. Digital science makes it possible not only to perform research more efficiently, but to transform science. And that's what we're doing right now. So, just if you thought it was just me making it up, there are other drivers. There's the National Innovation and Science Agenda, which was released in December 2015 by the Australian government. And they got 4 important pillars there. The first one says, there's no way we can be innovative unless we can embrace experimentation and accept that failure is inevitable. FAIL, first attempt in learning. We have to be able to navigate that and accept that sometimes things won't work the first time. The trick is to fail early and to go in there with the best of all intents. Of course, collaboration, and that was mentioned in the NCI talks yesterday. There's no way one agency can do this alone, one individual or even one country. Collaboration is going to be absolutely essential, and indeed the topic of the AMSI workshop we are hosting at the moment. The best and the brightest, this cannot be done without people, and that is going to be a huge challenge because the people aren't there in the numbers they are needed. And the last one is that government needs to lead by example. And I saw somewhere it says that government has been seen to be lagging behind the industry, and that has to change. Government has the capability to lead and take some of these risks. And a great example is the way we put out pre-competitive data for industry, for the mining industry to take risk of where to actually drill. But we have provided the pre-competitive data. And then there's some quotes down there around embracing risk, around innovation agility, and the fact that most of the jobs in emerging industries will require science, technology, engineering, and maths. We also got the Digital Transformation Office, and they came and spoke to us 2 weeks ago, and we are ramping up a collaboration with them. They are really driving how ICT should be deployed and delivered in government. And they are following the industry trends of agile, user focus, open source, and open standards. And they had a lot to say about that. The National Innovation and Science Agenda guys are going to come here and speak next Wednesday at 1 p.m. as well, for those who are interested. So the digital science strategy, it has identified 5 values that we must be to have this capability. We should be innovative, adaptable, open, collaborative, and quantitative. These are things we should strive for, because that is what we need to do to change where we need to be. Now, these 5 words, they might sound like motherhood statements, and it's easy to say we must be innovative. But in the strategy we identify that they all mean something very, very specific. So let me just go through that one by one, and also showcase the wonderful artwork of Products and Promotions who did this for us. Innovative. So innovation is not something you get by paying a group somewhere over there to do innovation for us. It's not the role of some specific individual. It's the role of everybody. And for that to work, we have to attract people with the right cultural and scientific skills. And we'll get into more detail in Trent's part of the talk of what that means. It also means empowering people to do things better. And that does not mean empowering people to come up with new things constantly. It means give them the opportunity to identify what needs to change, because it is the people who work close to the action who have the best idea of what might change at that level. That is not the only level, but that is an important level. And then, of course, valuing experimentation. So Trent will go into more detail about that as well. Adaptability. We have to acknowledge that the complex changing environment we're in is one where standing still is going backwards. Right? We have to acknowledge that. And then we need to establish governance that incentivizes change, because the world is changing around us. And we need to think big. And this is one of my favorite ones, because if you have a big idea of what we could be, there will always be someone who rightly say, well, that's impossible. We can't do that in a budget year, for example. Or that's too much. The idea here is to decouple the vision with the action. Think big, dream big. Say, in 10 years' time, what are we going to look like? And then what are the small steps we can take right now to go in that direction, and just keep doing that. That is really, really important. We need to be open. The world is moving to a situation where openness, for a lot of good reasons, is a great value proposition. If we make our data openly available, it will have a lot of impact for academia and research and other agencies. If we don't, it won't have that impact. And the money we could get by selling the data is minuscule compared to the other value proposition. The same goes for our software. By having open software, that's a whole talk in its own right that I'll be happy to give some other time. But it is quite clear that open source software creates a platform for collaboration. It also generally improves the quality of the software, because more people are looking at it and it is being peer reviewed. And thereby also you get a situation where you get better security of the software, because security vulnerabilities are being found, and that is well documented by scholars like Bruce Schneier, for example. Markus Hegland, who was my supervisor in the mid-90s, he was actually one of the people who got me onto that and showed me how that works. So that is, again, following what the Digital Transformation Office is saying, but we also know there are some very good reasons for it. So Geoscience Australia now got about 50 open source software projects on GitHub, so we are definitely going in that direction. We have started contributing to other projects, and we are getting contributions from collaborators. We need to be collaborative. We need to collaborate with each other. That means, we work on the same goal. We work with other organizations, and in the future it is quite likely we will be looking at citizen science and crowdsourcing through competitions, or crowdsourcing things like, did you feel an earthquake? Did your accelerometer in your phone actually measure something? Using those sort of new ideas is something that's quite likely and also identified by the European Union's program. Now, the last one is quantitative, and that is back to the discussion about what can you do with digital science and large data sets. If we can be more quantitative and less qualitative as a goal, there will always be the need for expert scientists making judgment calls. But where we can be, we should be quantitative so that we can, and we should automate our workflows so that we can establish provenance and reproducibility. So when we create a bushfire warning for a particular day, if we rerun that algorithm on the same data, it really should give the same result. And that is a really fundamental scientific tradition that we really need to embrace. So that's the last of those values. So in the working groups, we had a lot of talk about what skills do we need in the future. We had a quick poll and came up with this. What are the things that are needed more in the future? Software engineering, data science, math, statistics, and other things. This is not representative, but that was what the working group said. And I just happen to know that AMSI have just conducted a lot of interviews with industry and government agencies around what are the future skills needs, and it is very much in this space. I think the word is coding is non-negotiable. Coding is non-negotiable these days. So very much aligned there. And I would be very happy to get a copy of that study at some point. Leslie Wyborn and others have identified this back in 2014, the idea of the hybrid, the person who can bridge traditional or pure science with the technology, the digital technologies, the person who can model and translate the scientific question into something that is tractable on a digital computer, for example. That is very much the core of the skill that we need more of. Not only, but more of those sort of people. And there was a really good work that went into that, so we're not going to redo that, we're going to reuse it. And I apologize for this very busy slide, but this is sort of what we condensed it to. We're saying to deliver future science outcomes in a digital world, we need more digital natives. And I'll get back to what that means. But we need geoscientists who can understand geophysics and complex Earth systems. You know, we need them to be able to apply their science using digital method. We need them to work effectively with mathematicians and software engineers and data scientists. We need computational mathematicians who can model complex dynamic systems and solve things like ill-posed problems like we see in joint inversions, for example. We need them to be able to quantify uncertainty. And we have had a lot of talks about that in this workshop and recently around surrogate methods for quantifying uncertainty and how important that is, using sparse grids, for example. Understanding numerical issues such as rounding errors and stability, because if you don't understand that, the models can go anywhere. They can produce spurious artifacts. We need data scientists. Of course, we need data scientists who can model data and metadata, who can design and curate big data systems and data warehousing systems. We need them to be able to mine and analyze large and complex data sets through machine learning and predictive modeling. Again, machine learning is a really, really hot topic. Then we need software engineers who can actually build robust digital systems that are actually operational. They can automate scientific workflows and who can leverage high-performance computing infrastructure, for example, through parallelization, because there is a misconception sometimes that we can take a desktop model that does something and we can just put it on the NCI and it will scale up by itself. That is not the case. Software needs to be engineered with parallelization and vectorization in mind for it to actually scale up. And I can certainly assure you that my first attempt at parallelizing that's about 25 years ago, the very first versions always scaled down. You get it to work and then it scales down. You put more and more processors at it and it goes slower and slower and slower. And conversely, I have had examples where it went faster and faster and faster, and I was very happy, but I discovered that it was wrong. So that's where unit testing and system testing and all these other things come in. Anyway, we also need culture. So these are skills, and without culture, they mean nothing. If we don't have the ability to collaborate, communicate, and be adaptive, and focus on value, So value is, for example, protecting people from bushfires. Right? Value is, for example, providing GPS accuracy down to 1 centimeter. Value is telling the mining industry this is where the next gold deposit is, for example. That is value. Value is to be able to tell what is happening with the groundwater in the Murray-Darling Basin, for example. So a digital native, it's sort of a catch-all term. We learned that at Australia Post when we went down and visited them last year. A digital native is a person who live and breathe this, right, and really understand what these technologies can be used for and are not afraid to do coding with them. There's also the concept of a digital nomad. A digital nomad is someone who can easily refocus and change where the value proposition is and is not embedded in one work area for 10 years, for example. And we need a lot of that. That is a non-negotiable requirement from the CEO, that we need to be flexible so we can move to where the priorities are. And then, of course, we need STEM skills. So I picked that picture up there. Science, technology, engineering, and maths. They're the skills we need. The examples of future challenges, as I mentioned, are surface groundwater interactions, positioning, prospectivity of minerals, visibility of changes in land cover across the nation, understanding geological structures that can't be observed, provide warnings and risk estimates, and many, many more things that we haven't even thought about yet. And there's a long list here, and it's actually longer than that, and I won't read it out, of common disciplines that are applicable not just in one area. Like, for example, inversion is used across the agency and across geoscience, and so is fluid modeling, but many other things. Machine learning is another big one that's coming on. So we need to really embrace these disciplines. They don't just exist in one area, they exist across the agency. So the last part of my talk here will discuss 5 specific strategic initiatives we have proposed to actually implement this change. They are high level, but they're specific. And obviously what we are looking to is to work out the details of that as we go. The first one is to access the right mix of skills. And as I alluded to earlier, and as Anthony said, that is going to be very, very difficult. So we have to be really creative about how we do it. And that is, we need things like, recruiting people is one way, but it won't be the only way. We will be absolutely needing to collaborate with academia, joint PhD students, linkage grants, crowdsourcing information, for example, through Kaggle competitions, as Stuart mentioned, was alerting us to just the other day, where you put a problem out and you have a competition, a bit of a prize, and suddenly you get 100,000 people looking at your problem rather than 10 or 1. Those sort of things we need to do. We need to go to academia and tell them that we are not only recruiting geologists, for example, because I think in academia they wouldn't know that we are starting to play in this space. So we need a whole raft of creative new ways of working there. We need to establish an agile way of working, which is the topic of Trent's part of the talk, so I won't really go through it, but that is about being value-focused, it's about being collaborative, and it's about being adaptable. It is the industry trend, and the Digital Transformation Office are already doing it. I went there last Wednesday and saw 3 projects, government projects, embedded in there, working in an agile way. So Trent will explain that in more detail, but that's where it's going, and there's no discussion, no discussion about that anymore. That's where we need to be going if we want to be flexible enough to achieve our value. We need to recognize that what we do needs the whole full spectrum of digital technology, right from the mobile phone through to workstations, through to the high-performance computing. And I put a picture in of a quantum computer as well. If they come online, we will need to use those as well. But the point is we really got to harness the whole thing, because not everything fits the NCI, because it is for the big national scale work. But there is still a room for doing the scientific computing on smaller devices. Take, for example, a GPS receiver. Now, not that we are developing it here, but it's full of scientific computing on a little handheld device. So we shouldn't exclude those sort of things. It has to be fit for purpose. Then we need to improve our planning and program delivery. And I took this picture from Monty Python and the Holy Grail, get on with it. We are in a situation where for example, our work planning, I think it's fair to say, is not really conducive to getting work done. I think that would be a fair statement, and we need to improve that. There are some ideas around capacity funding and time boxing. The idea is that you say, well, this is the capacity we have, these are the people we have, these are the teams we have. Go away and work for 3 months on this, and set your own priorities together with the business owner or the product owner, and actually see how far you go. And then you decide whether to do another 3 months or not. And if not, you have actually saved up some capacity. And if yes, you have put it where the right priority is. And we really, really need to rework that. And those teams need to be empowered so that they actually can make some decisions at the right level. And documentation, we need to make sure that documentation is read by someone and it makes sense to someone. So when we write a document, we need to be absolutely sure that it's the right thing we write and it is something that someone needs to read, not just to have it because of meeting a deadline. And I think that if you look at Agile, that is exactly the key here, and I see a lot of nods in the room. It's the time is right to actually try to revisit how we do this, because our time is very, very precious. And then we need our procurement to support innovation. So if a team says we need to trial this thing to find out if that's the right tool, we need to have a procurement in place that can support that. And then finally, we need to formalize digital science leadership. Digital science should not be led by some random director from ICT. It should be led by the chief scientist, because it will underpin pretty much everything we do. So we are explicitly suggesting that. And we also need to develop a vision. This is something that happened in October. We asked a naive question: what are the future scientific products we'll be developing in 5 to 10 years? What are they? What do they look like? And while we do have a high-level strategy in this agency, we actually don't have a picture of that yet. So we started that, but quickly realized that was way, way too difficult and big for us to sort out ourselves. So the chief scientist is going to run with that and create that picture, because that will also help guide where we're going. So I'll stop here and hand over to Trent, and we take questions together. Thank you.
Hi everyone. So as Ole said, I'm going to be, I guess, drilling in a little bit more detail on Agile and what we think it means for GA to adopt this new Agile way of working as articulated in the digital science strategy. So I'll start with the Charles Darwin slide. It's not the strongest or the most intelligent species that survives. It's the one that is most adaptable to change. And really, this is a great statement that aligns really well with the Agile agenda and the reason behind it. We're ultimately trying to organise ourselves into a way that is far more adaptable to change, and certainly give people the opportunity and remove as many barriers as we can for people so that they are able to adapt. So Linda Rising defines Agile philosophy at quite a nice, high, but at the same time tangible level, by saying that Agile is about establishing an initial long-term goal, but being prepared to adapt it as you learn. This concept of an evolving vision, I think, is a really appealing one for me, at least. However often we document a vision, document a strategy, the truth is that the world around us is constantly changing, and whatever we've written down within our minds, we're certainly getting a sense of an evolving vision, and we're constantly learning, and we're constantly slightly changing our way of thinking. This idea of dreaming big and starting small is key. Agile is definitely not about throwing the vision out and just starting to do blindly. You certainly have a big picture, and you're constantly working with that big picture in mind, but you're taking small steps towards that vision. So the Agile Manifesto, this is, I know it's done the rounds a lot here in presentations recently, but I will cover it again. Back in 2001, I think it was, a bunch of nerds got together and took the time to articulate what focusing on value meant to them. So they said that we've come to value individuals and interactions over processes and tools. That is to say, processes and tools are very useful things. We want processes and tools, but we understand that the role of processes and tools in most cases is to support individuals and their interactions. So if there's a better way outside of the process or the tools that are provided, then we should certainly be looking into moving forward and interacting with one another in the best way possible. Useful products over comprehensive documentation. Sure, it's a wonderful thing to have comprehensive documentation about a product, but what's it all really worth if the product doesn't work? Customer collaboration over contract negotiation. That idea again, that things are constantly changing. We need to have open relationships with our stakeholders, understand the outcomes of our clients, and make sure that we're constantly collaborating with them and providing them with an opportunity to be a part of an objective and responding to change over following a plan. So again, a plan a project plan, a document is a point-in-time version of what we think the best way forward is. The truth is the world around us changes and we need to change in response to that. So really what we're talking about here is taking incremental steps towards a broader vision rather than trying to take one big step. We can't possibly understand what it takes, and history certainly suggests that we can't understand what it takes to get to the final outcome in the most efficient possible way. By taking incremental steps and constantly taking a brief moment to look back and see how you've gone, you really do have an opportunity to stop, learn, engage, and pivot. So really we're talking about building teams that embrace change, collaborate, are empowered, focus on quality at source, and also focus on value. So I'll drill into those in just a little bit more detail. So what do we mean in practical terms when we're talking about embracing change? We're talking about showcasing what we're up to frequently with all stakeholders, so our team, our management, our clients, everyone who is frankly interested in taking a look at what we're up to allow that continuous validation of our business case and make it far easier for us to at the end of the day change early in the piece rather than late in the piece. So collaboration. We are really well placed in this organisation to collaborate in that we share a building. The vast majority of staff of Geoscience Australia are within a couple of minutes walk from one another, and that is a wonderful thing. I know I certainly make the most of that. I'm constantly walking around the building, and there is no substitute for face-to-face communication. Empowerment. This idea that we build projects around motivated individuals. The truth of the matter is that the vast majority, at the very least, the vast majority of staff at Geoscience Australia are here because they're passionate about what Geoscience Australia does. Often they're passionate about particular things that Geoscience Australia does, and we should absolutely seek to harness that. We want people to be motivated and stand 100% behind what they are working on, and I think we are already in, frankly, a really good state from this perspective, but there's always room for improvement, isn't there? So we should absolutely keep it in our minds that we want to make sure that we're organising ourselves in a way that allows people to work on things that they're motivated about. So what is the role of management in all of this? It is to provide our staff with an environment in which they can thrive and which they can focus on value. Devolving decision-making to the lowest possible level. Of course, there are management structures. We're not going to do away with management or anything like that. They're always going to exist at some level, but making sure that we're providing our staff with as much autonomy as we can so that they can make decisions on the ground and focus on value is absolutely key. So quality at source, what do we mean by this? I'm sure we've all seen at least one situation in the past where I guess a team or a person or an organisation has focused a great deal of effort for a long period of time in building a product that they think is top-notch, absolutely hitting the mark, and then they release it, they share it, and they get that unfortunate shock that maybe it wasn't quite hitting the mark as well as they thought it was. So this is about making sure that we're thinking about quality from the outset and doing that ultimately by making the work that we're doing as visible as early in the piece as we're developing the product as possible. And finally, focusing on value. I quite like this picture. I think it really tells the reality of the story when it comes to prioritization and decision making. We're not dealing in a simple situation where we're either making a decision to do something of value or we're making a decision to do something that is not of value. It really is a question of which direction delivers the most value, and that is an incredibly complex thing to get our heads around. We believe that the best way to achieve prioritisation is to make sure that we are open, visible, and maintain open communication with our stakeholders to ensure that the features, the products of the highest value do get prioritised. Also making forward-facing decisions. The fact that we've spent millions of dollars on something over a period is not necessarily a reason to spend another few $1 million on something into the future. If we start making decisions on the basis of where we are, where we could be if we spend a particular amount of money and not worry at all about how much investment we might have put into to something, then it really puts us in a position where we're making sure that we don't throw good money after bad. So all of this communication and openness and collaboration that we're talking about really aligns very well with GA's inclusive culture agenda. We are absolutely 100% behind helping to make sure that GA is an inclusive workplace that ensures everyone has equal opportunity to contribute, participate and progress. So of course, you know, when we think about this, we think about minorities and those kinds of things, but we should also think about this in terms of staff versus management. You know, making sure that staff have absolute maximum opportunity to influence the direction of the organisation is hugely valued. 600 brains are better than one. We all know that. So this is just a little picture trying to articulate the importance of both alignment and autonomy. If we look in the top left-hand corner where we have a team of people that are highly aligned, not particularly autonomous, we're in a situation where the manager on the left there identifies the problem and identifies the solution. We need to cross the river, so build a bridge. In the bottom right-hand corner where we have a great deal of autonomy and not a whole lot of alignment, I'm sure we've got a bunch of people working on great things, but how is it all coming together? Where we want to be, ideally, is where we are both aligned and autonomous, in the top right-hand corner there, where staff are empowered to both identify the problem and come up with the best possible solution. So that solution may be, in the case of crossing a river, to build a bridge. It may not be. But you can be sure that if you've got, in this case, 4 brains working on it as opposed to one, they're certainly more likely to come up with a great, innovative solution to the problem. So in practice, when we're looking at the way that GA works, what are we talking about? We're talking about building a situation where we have a series of implementation or delivery teams with many disciplines. It's a multidisciplinary digital science delivery team that is empowered to focus on value and to work. The role I guess the relationship between these teams and leadership is one of collaboration. It's not a case of program leadership being an authority over implementation teams. We all have roles to play within a program, and the best possible way for us to achieve value, focus on value, is for all of us to work together and make sure that we have as many brains in the mix as possible. So we spoke earlier about iterations, the idea that we take small steps at a time, but what does that actually mean at its core? How do we follow through and complete an iteration? We suggest there are 4 steps in an iteration. So at first we plan for that small step. What are we going to do in this small step? We follow through, we do it. We share what we've done and take feedback on it. We learn from what we've done. We learn from the feedback we receive, and we adjust our direction. We correct, we pivot to make sure that we head in the right direction. We're asserting that this is a process that can apply to all levels of management. From the individual level right up to an entire organisation. Obviously, the higher the level you go in the organisation, the longer the increment is likely to be. But the key really here with this potential multi-layered approach is that we believe that there is a great deal of value in cadence between these different levels. If you get cadence right, if you have these different levels working in a synchronized way, then visibility, that is reporting, can happen organically, or at least more organically than it often does at the moment. So I think everyone would like to see a situation where they didn't feel the burden of reporting as they might feel it at the moment. So if we can achieve the same level of visibility without feeling the burden of reporting, that's got to be a good thing. So pulling all of those pictures together into I guess a bigger view, we've got the program team and the delivery team, or the program leadership team and the delivery teams working together, all part of a program team. And in this case, we're talking about a higher level increment that we're calling a program increment, where for a 3-month period, the entire team, the delivery teams, the program leadership stakeholders all get together and they say, what are we going to do? What do we think we're going to do for the next 3 months? And all together, the idea is that they plan and do and showcase and pivot at the end of that 3-month period as an iteration. Once the planning is done, the delivery teams are in a position in their own right, without the need for too much involvement from the program management, program leadership layer to plan their work in more detail, focus on the specifics of what value looks like to achieve the overarching objectives of the program increment, and figure out how they can break the work down into smaller cycles here. So you'll see within the program increment we have in the middle there a mid-cycle review that coincides directly with the end of half of the sprints. That means that the outcomes that are coming out of the learnings of sprints feed in at the delivery team level, can feed in to that higher level increment. So what are we doing? What are we up to as far as making this happen? We're collaborating very closely at the moment with the Australian Geoscience Data Cube program to establish a new agile way of working across the program. So that's across many disciplines, from remote sensing to data science, spatial analysis, systems engineering, stakeholder engagement, all of these skill sets working in a multidisciplinary way So this kind of multi-layered approach, we're going to give it a whirl. We're also reorganising a subset of ICTIS resources, particularly from the data and the software engineering sections, into deployable multidisciplinary agile teams. What they work on, we're still working on the specifics of that. It'll, of course, align with the work planning process that's currently underway. We're collaborating closely. It's early days at this point, but we are collaborating closely with corporate services to start to align the project management framework with agile philosophy. They are very interested in what we're talking about. I understand that the PMF is up for review in the coming little while, so we'll certainly be very involved in that. Arranging organisation-wide agile training. If you're interested, get in touch. And we are exploring a wide range of options for accessing digital science skills. One big part of that, frankly, is networking, and we are in the midst of the AMC conference, which is a really good example of the kinds of novel approaches that we can think about taking to start to look at different ways of bringing the right skills into the building. And I think I will leave it there. The world's changing. Let's embrace it and seize the day.